ahead and take a look. You can notice that this is recording now, so we're all set to go. Okay, so here are what your notes look like. Section 8.5 is on one application of determinants. Okay, so we've already learned how to use matrices, row operations, augmented matrices, all that sort of stuff, Gauss-Jordan elimination, all that sort of thing, to solve systems of equations using matrices. This is another really cool technique. You may like this better, you may not. It is kind of cool though. So you'll notice that system right there has appeared in a couple of the notes that we've already done. So x plus y equals 8 and x minus y equals 4. If you stopped and thought about that for just a second, you could think, okay, I've got the same number and then I'm adding a little bit and I get 8. I've got the same number and I'm subtracting a little bit and I get 4. What's x? 6. And what's y? 2. Okay, so the answer to this system is 6 and 2. We already know that. We've seen this before. But we're going to talk about how to find the answer a different way, and it's using determinants, and it's something called Cramer's rule. Okay, so here's what we need to do. In order to solve a 2x2 system using determinants, using Cramer's rule, we've got to compute 3 different 2x2 determinants. So we use this big capital D right here, and that stands for the determinant of the matrix of coefficients. We've kind of already talked about what the matrix of coefficients would be. It's going to be just the coefficients, okay? So if I were to look at this one right here, D is going to be the matrix of coefficients. So that's going to be 1, 1, 1, negative 1. That's what D would be. Okay? Now, D sub x is a little bit different. D sub x is going to be the determinant of the x matrix. And here's what we mean when we say the x matrix. The x column of that matrix of coefficients gets replaced by the, we'll call it the answer column. Okay? So here's what I'm going to do. This is the coefficient matrix. I'm going to replace the x column with the answer column. So that x column, instead of being 1, 1, is going to be 8, 4, and the y column still stays the same. Okay? Now, we're going to do the d sub y, the determinant of the y matrix. And in this case, the y column gets replaced with, again, the answer column. Please don't make this mistake. Everybody watch, please. This is a common thing. Remember, you always start with the matrix of coefficients, and you just replace the columns one at a time. So we replace the x column with 8, 4. Now we're going to replace the y column with 8, 4. And this comes back, and it's still 1, 1. Everybody clear on that? Please don't make this 8, 4. Can anybody tell me what would happen if you made it 8, 4? If both of these were 8, 4? Yeah. The determinant would be 0 because you'd get 32 minus 32, right? Okay, so please don't do that. Don't make that mistake. That's very common. Okay, are there any questions? Okay, and are those determinants pretty easy to compute? Diagonals, if you wanted to do cofactor expansion, that would be fine, but that's going to be pretty easy. Now here's the awesome part. This is what Cramer's rule says. Cramer's rule says that the x that we're looking for is the determinant of the x matrix divided by the determinant of the matrix of coefficients, and guess what y is? D sub y over d. So all I need to do is compute those 3 determinants and then make a little division problem for each one of them. So let's go ahead and compute this. This is going to be negative 1. Write a minus for the upward diagonal, and that's going to be 1, so I get negative 2. Multiply down, that's negative 8. Write the minus for the upward diagonal, so that's going to be a 4, so this is negative 12. Multiply down, that's a 4. Write the minus for the upward diagonal, and then this is going to be an 8, so we end up with negative 4. Once I have those 3 numbers, all I have to do is remember what Cramer's rule is. Cramer's rule says this, that x is going to be the x determinant, which is negative 12, divided by the determinant of the matrix of coefficients, which is negative 2. So the answer is 6, just like we knew it would be. Okay? And y is the determinant of the y matrix divided by the determinant of the matrix of coefficients. So that's going to be a 2. Got a lot of numbers that are circled here. Don't forget, the point of solving this is to find where these lines cross, to find a point that works in both of them. So we're finding an ordered pair. We're literally finding, if we were to graph these, where they cross. So the answer to this is an ordered pair, 6, 2. That's it. Okay? Any questions? Easy enough? Okay, sure? Okay, so let's go ahead and let's take a look at this. So if Cramer's rule says that for a 2 by 2, x is the determinant of the x matrix divided by the determinant of the matrix of coefficients, or I'm going to say d sub x divided by d, and y is d sub y divided by d, what do you think Cramer's rule says for a 3 by 3?
D sub z divided by d.
Yep. So this is, we're going to add this. D sub z divided by d, d sub y divided by d, d sub x divided by d. Okay? So how many determinants are we going to have to find on this? We're going to have to find 4. We're going to have to find 4. Now, everybody listen carefully. That means for every single one of these, you find 4 3 by 3 determinants. Okay? When we were learning how to do determinants, you probably only did 4 or 5 altogether, and yet every single one of these 3 by 3s is going to require 4 3 by 3 determinants. Okay? So let's be smart about this. And even on the homework, I don't mind if you do this. I don't want you to do everything on every single problem. What I'd like you to do is maybe pair up and split them up just a little bit. So here's what we're going to do. Let's make sure that we all have this correct. Let's write down what D is. You go ahead and write it down. Double check, make sure you got it right. Okay, this is probably the most important one, isn't it? Yeah, probably the most important one. Everybody got that written down correctly? Okay, now let's write down d sub x. D sub x is going to be that exact same thing with the x column replaced. So this is going to be negative 4, 4, negative 11. And then we just write these guys down again. Everybody get that? Okay. D sub y, remember, we bring back the x column, so 1, 4, 2. We certainly don't touch the z column at all, but it's the y column that gets replaced by the answer column. So this is going to be our negative 4, 4, and negative 11. Okay. Again, try and keep things nice and neat, keep them orderly, spaced correctly, and all that sort of stuff. And then the last one, we want to find out what d sub z is. So we're going to replace the z column with the answer column. So negative 4, 4, and negative 11. And then bring back those other two. So 1, 4, 2, and negative 1, negative 3, negative 2. Okay. Everybody good?
Yep.
Okay. Any questions? Okay. Do you want to do all 3 of these? Okay, I really don't. So here's what we're going to do. Okay, would you guys do D? Okay, these 6 people right here, they're going to do D. Okay, you guys do D sub X. You 6 people do D sub X. Would you guys do D sub Y? Okay, and I'm going to do D sub Z. Okay, and when you do the homework, I don't mind if you break it up this way. But we're really depending on each other, aren't we? Okay, who has the most important one? You guys do. Woo! Okay?
Bob, no, that's not.
Yeah, Bob, don't. Okay? Because that one is involved in every single one of them. Okay? So if anything, if you're working in a couple of teams, you may both, if you pair up, you may both want to do that one, make sure that one's correct, and then break the other ones up. Yeah.
So when we're doing this on like the homework and stuff, could we solve for just d sub x, d sub y, and then just plug those 2 into the equation to get y?
Sure, you could, but if you're going to do that much work, yeah. I mean, it doesn't matter, but it does say do it using Cramer's rule. If this were on a test, you'd have to show all of the determinants. Okay?
All right.
And just so you know, on a test, even in like 1050 or something like that, a lot of times they'll say just find one of the variables. Okay, so you only have two determinants to compute. Yeah.
Do you want us to use like diagonals or dimension?
That's the cool thing. It doesn't matter. Should you only practice diagonals? No. You better know how to do cofactor expansion or expansion by minors. You have to know that method. That's going to make what we do next week a heck of a lot easier. Okay? All right. So I'm going to go ahead and find D sub z. You guys find the other ones. How are we doing? If somebody's done, if you want to double check my work on D sub z, but I think I did it right. Let's see. Okay, what's D? Negative 1? Okay.
I didn't do anything wrong.
Good job, Bob.
The first time. That's okay.
Okay, that's good news, isn't it? It's nice when we're going to be dividing by a 1. Okay, how about D sub x? What'd you guys get? There were 6 of you and nobody got anything?
I got -1, but they
Yeah.
-1? Josh, what'd you get?
I didn't get that.
What'd you get?
I got 77, but I don't think that was
Okay, that might be interesting.
Yeah.
Jared's, what did you get? We ran into complications. Okay, should we say it's -1?
Yeah, it's
Okay.
-1. My bad.
Okay.
Seriously? Wasn't
And D sub y, what did you guys come up with? -2? You guess? So how many of you got -2?
Emily, I got -18. She got -14. Oh, +14. Never mind.
That's a point.
Okay, how about we do this?
It seems like we should have spent more time on
Okay, so we went through and we did it this way. Please be careful. If you're careful, you're probably going to end up getting this right. Okay? So, write down the sign associated with the position. Write down the number that's there. Simplify a little bit at a time. You'll notice that we didn't get too carried away. We just added these together. It's nice when there's a 1 out front. On this one right here, we had a negative inside, a -1 on the outside. Multiplied them together. There we go. Okay, are there any questions there? Okay, are you guys pretty convinced that you got that one right? Okay, so we're good with this one with d sub x? Okay, I believe that one's correct.
Yeah, definitely. We just figured it out.
Good, and what would be nice about this one being -3? That means x is -1 over -1, y is -2 over -1, and z is -3 over -1. Whoops. Okay, so what's our answer? What's our ordered triple? 1, 2, 3. Now let's double check. If you put in a 1 minus a 2 minus a 3, that would be 1 minus 5, that would be -4, right? This would be 2 minus 4 minus 9. Does that work? Yep. Okay. Got it right. Okay. Any questions? Okay. This is why you'd want to be very careful and why you'd want to split them up. So let's take a look at this next one. Okay. Let's see if we can do a little bit better here. Okay. So let's do this. Let's write down D. Let's make sure everybody can write them down correctly. Good there?
Yeah.
Okay, and then go through and replace them one at a time. Okay, let's do it in this order this time. Okay, I'll do D. Okay, let's go backwards. You 4 over here, you guys do D sub x.
Okay.
You guys do D sub y, and you guys do D sub z. Okay?
Are you really surprised by the word I said?
Not really.
Yeah, you do.
Well, Sam, you have 4 years.
I still can't figure out what they're doing.
That's true.
Which is pretty.
And again, if you write it down wrong, you've got no hope of getting it right.
That's up to you.
Hey. Do it wrong. It's a great message. I think it.
Who's around and comes up with something like this?
Woo! You know what? Maybe got really bored one day.
Genius. Oh.
You got really good. Okay. Okay. Oh, here we go. Hey.
So one month.
We are totally I use the button.
Hey.
When I use the.
What'd you get?
15.
What? On D sub X or D sub Y? I got 19.
What'd you get?
D sub 19.
What?
No, on D sub
You
Y.
guys got -9? You people.
We haven't been
What
doing
did you
that
get?
for like 10 years, 20 years.
-18?
I did something wrong. 77 in fact. So I need to go back and figure out where.
Okay, we ready to say for sure? What do we have right here for D sub X? What do you have? -18. We're convinced it's -18. Okay, what about D sub Y? 20, positive 27? Okay, 27. Okay, and what about D sub Z? -9. Okay, now, considering the fact that we're normally pretty nice about the way we put these together, do those numbers look good as far as Cramer's rule goes? Why? Okay, because the determinant of the matrix of coefficients is 9, and all of these numbers right here are multiples of 9. So that means x is going to be -18 over 9, y is going to be 27 over 9, and z is going to be -9 over 9. So we get a -2, we get a 3, and we get a -1. So we've got -2, 3, and -1. Okay? Any questions? Okay, now, let's see. Who did the y's last time? Did you guys do the y's on the previous one? Okay. I am not convinced that this one right here is correct. Okay? I think it's a -4, but you may want to double check. Okay? You sure? Okay. All right. If it is, then we're good. Okay? All right. Yeah. Yeah. Okay. Any questions? Okay. All right. Let's take a look at the bottom of this page. So Cramer's rule involves a lot of work. Okay. If you've got a computer or a calculator that can just compute determinants really quickly, it's a lot easier. And the nice thing about this is think about what we're doing. Okay. We're doing a bunch of arithmetic. Okay. And you can teach a little kid to do arithmetic. Okay. Imagine you had all the kids in your neighborhood, you come over, you show them how to multiply some things together. Okay, say they're 5th or 6th grade. They could probably do this, and you could keep them busy all day getting answers for you. Okay? So when we can reduce a process, a very complicated process, to some very, very simple procedures, we just put all those procedures together, and out comes a very complex answer to a complex problem. Literally, this is the point where the planes cross. Not something a 5th grader could understand, but something they could help you figure out. Okay, if you just said, okay, I just need you to multiply these two numbers and tell me what the answer is. Okay, and threaten them to make sure they get it right. Okay.
Threaten them.
So, with candy, of course. Okay.
I would like to throw it.
Or friendship with Bob, whatever the case.
Okay.
Ouch.
Oh, did I say that out loud? That was so weird. Okay. So
You go, you're immortalized.
it's kind of cool that it works that way, but can you think of a time when Cramer's rule wouldn't work? So if you look at the way that this is set up, okay, we've talked about 3 functions that have domain issues: division, even roots, and logarithms. Does this have one of those operations in it?
Yes.
Emily, what's the problem here?
If your just determinant E equals 0, then well, we're gonna screw
Yep, every one of these would blow up, right? Wouldn't work, okay? Can't divide by 0. So it's not going to work when D is equal to 0. So it's always nice to have a backup method. So row operations, substitution, elimination, graphing, all of that sort of stuff, okay? So let's take a look at this one right here. Let's figure out whether or not Cramer's rule would work on this. Let's write down what D would be. D would be 1, -1, -1, 4, 1, 2, and then 2, -2, -2. Okay? Now, take a look at that for just a second. There are a couple different things we could do with this one. Okay? We could go through and we could actually do we could actually do expansion by minors and find what the determinant is. But take a good look at that for a second. Take a look at the first row and take a look at the last row. The first row is 1, -1, -1. The last row is 2, -2, -2. Remember, this represents a system of equations, so all of those normal operations that I can usually do. What if I took the first row, multiplied it by -2, and I added it to the third row? Okay, this would be -2. This would be 2, and this would be 2, right?
It'll be 0 now.
And if I added those together, what I'd have is 1, -1, -1, and 4, 1, 2, and then this would be 0, 0, 0. Now, if you were paying attention and you got to the end of the assignment in section 8.4, there was a big, ugly matrix. I think it was a 4x4 or something like that. But one of the rows was all 0. So remember our rules for finding determinants. If you're going to do expansion by minors, pick the easiest row to expand on or the easiest column to expand on. And by the easiest, we mean the most zeros or the smallest numbers or the fewest negatives, however you want to think of it, right? So which row would we expand on?
Row 2.
That's why we want to be Bob's friend. Right there. Okay?
It's obviously row 1.
So every one of these, I'd do 0 times its minor, 0 times its minor, and then 0 times its minor. Doesn't matter what these determinants end up to be. Every one of them is multiplied by 0, so the determinant would be 0. Okay? So we'd say a big nope, and the reason is the determinant of the matrix of coefficients would end up being 0. Okay? Does that make sense? Okay, so there are lots of nice shortcuts to things, but a lot of times if you've got a shortcut, it's got a pitfall. You've got to know where that shortcut breaks down. Okay, are there any questions? Okay, we're now going to talk about some really cool applications of determinants. This is not in every textbook. I can tell you this is not in your 1050 book or your 1060 book. Okay, there's a way to find the area of a triangle using determinants. Okay, it's actually pretty darn cool. All you need are the 3 points. You don't need to find the base and the height or anything like that. Because normally, to find the area of a triangle, you'd have to do 1/2 base times height, right? The awesome part about this is, all you need is, tell me where the 3 vertices are. Give me the coordinates of the vertices, and we can figure out what the area is. So here's how it works. It's going to be 1/2 the determinant of a 3x3 with the first point right here with a 1 on the end, the second point right here with a 1 on the end, and the third point right here with a 1 on the end. Okay? The only thing we need to worry about is whether or not it's a plus or a minus. If it turns out to be a negative, remember area can't be negative, so we just change that to a positive or multiply it by a negative. Okay? Yeah, you could just think of it as taking the absolute value of whatever the answer is. Okay? So let's run through and let's find the answer of this. This is from a branch of math called linear algebra. It's something that you take probably after you took Calc 2 or maybe Calc 3 if you end up going into engineering or math or physics or something like that. So here's what we do. I'm going to put 4, 3, 1. I'm going to put 2, 2, 1. And I'm going to put 1, 0, 1. Yeah?
Does it matter where the points go?
No, that's the cool thing. So if I wanted to start at the bottom and put the 1, 0, 1 at the top, and then the 2, 2 here, and the 4, 3 at the bottom, the only thing that's going to happen when you switch the order, switch the rows, is it's going to change the sign of the answer. That's it. It's going to be the same number. It's just going to be a different sign. Yeah.
Why is it 1 on the ends?
I haven't looked into a proof of why this works.
What does everything do?
Yeah, do you want to find a proof for this? I'm sure we could find one.
It's
Okay?
not, because the shape of
Okay,
math.
take a good look. Don't say anything out loud. Pretend this problem, that determinant right there, was on a test. Which row or column? Don't say anything out loud.
Bob, put your hand up.
Should we call on Bob?
Yes.
No.
Oh, give him a chance.
Rousing endorsement.
Bob.
Okay, Bob, we're going to call on Emily.
So ready.
Emily, which row or
I
column?
use the bottom row or the far right column.
Okay,
But
bottom row.
probably.
Probably the bottom row because it's got a 0 in it, right? Anytime you've got a 0 there, it simplifies the multiplication. So, sign associated with this position? Positive. Number that's there is a 1. Let's find its minor, cross out the row and the column, so 3, 1, 2, 1. Doesn't really matter, but the sign associated with the position is 0 or is negative, but it's got a 0, so I'm not even going to worry about that guy right there. Sign associated with this position? Positive, so that's going to be a 1, and cross out the row and column, 4, 3, 2, 2. So here's what we've got. We've got 1, 3 minus 2, 0, and then, let's see, 8 minus 6. So we've got 1 and 2, so that's going to be 3. Okay, is that the answer? That's just the determinant, right? In order to get the area, we've got this plus or minus 1/2. So plus or minus 1/2. So the answer is 3/2. 3/2. 3/2 is the answer. We get in the habit of just finding determinants. Don't forget, if you're finding the area, it's got to be that 1/2 out front. Any questions? Maybe. It's an easy, cool application, and it's not like Cramer's rule where you have to find 4 determinants. You just find 1. Everybody good there?
Yeah.
You want it on the test?
That's extra credit.
Okay.
Yeah,
all right.
I got it.
All right, we'll see. Take a look at this one right here. Okay, don't say anything out loud. I think everybody here is capable of figuring out why this is the case. Okay, what does the word collinear mean? Along the same line. Okay, so stop and think about this. Again, don't say anything out loud. Everybody deserves the opportunity to figure this out for themselves. It says 3 points x1, y1, x2, y2, x3, y3 are collinear. They lay on the same line. If and only if, so only if that determinant that we looked at before is equal to 0. So think about why that would be the case. And it might be worth glancing up. Let me make this a little smaller. Glancing up at that right there, because it has something to do with that. Josh has an idea. Anybody else? Dylan? Sam? Lily? Anybody else? If that determinant is 0, they have to be on the same line. And it comes from this idea where we just talked about how to find the area of a triangle using this funky determinant. Emily thinks she knows? Okay, raise your hand if you think you know at this point. Okay. Autumn Rose, what do you think? Okay, so here's the way we want to think of this. Okay, if this computes the area or helps compute the area, if this is 0, how would you get a triangle with 3 points that doesn't have any area? Magic, I suppose, would be one way. But wouldn't they all have to be on the same line? I mean, because the minute this comes up on this side or down on this side, we'd have some area. But if it's right on that line that contains the other 2, the area has to be 0. So if this determinant is 0, the area is 0, and the only way to have that happen is that they're all on exactly the same line. Okay? So that's why it works that way. So the question here is, are those collinear? How would we check? Put them into that little determinant, right? So -2, -2, 1, 1, 2, 1, 4, 6, 1. Which row or column?
Probably the far right.
Probably the.
The
Third column.
Okay, let's talk about them the right way. Remember, we're talking in terms of rows and columns. We're going to expand on the third column. So this is going to be sign associated with is positive, numbers 1. Cross out the row in the column. 1, 2, 4, 6. Sign associated with the position, negative. Number that's there is 1. Let's see, cross out the row and the column. So -2, -2, 4, 6. Sign associated with the position, positive. Numbers of 1. Cross out the row and the column. -2, -2, 1, 2. And let's see what we end up with here. Am I right?
No, because the -2 should be a -4. And the third.
Oh, there we go. Thanks.
So,
Yep, silly arithmetic mistakes. We good here? Okay, so we've got -2. This would be -4, but that's going to turn into a +4. This is going to be -2. So we end up with 0. So what does that mean? Collinear. They are on the same line. Okay? Everybody good?
Yep.
Okay. All right. Here's the last one. Last application of determinants. Okay, and again, you're not going to see this in very many places. Okay, so this would be something that you could kind of lock away. If it comes up again somewhere down the road, you're going to be, oh, okay, I've seen that before. Okay, take a look at this, and again, think about why this would work. This is the 2-point form of a linear equation. It says an equation of a line passing through the two distinct points x1, y1 and x2, y2 can be given by that right there. Okay, if I have subscripts on these, are these variables? No, they're numbers, right? So this would be an ordered pair, 2, 3, or 5, 7, or something like that. Okay, these have subscripts on them, so this would be another point. So this is a point, say it's over here. This is another point, say it's over here. So this is x1, y1, and this is x2, y2. Okay? What about those two? Are they variables or are they numbers? Is that a point? It's a variable, right? Okay. So this, we don't know where it is. We don't know what point they are. We know this one's here, we know this one's here, but we don't know where this one is because those are both variables. But if the determinant here equals 0, then what do we know about this point?
It's on the line.
It's got to be on this line. It's got to be somewhere on the line that contains those two. Does that make sense?
Yep.
Okay, so let's go ahead and find the equation of the line that goes through these 2 points. So we're going to do x, y, 1, -2, -2, 1, 1, 2, 1. Again, pick the easiest row or column to expand on. Again, we're going to call it the third column, right? Third column's the easiest. 1, -2, -2, 1, 2. Yeah.
Wouldn't it be the top row if we're finding the equation of a line instead of have the x and the y?
It's not going to matter. It'll work either way. You can do the first row if you want. In fact, go ahead and do the first row. Cross out the row and column. See, cross out the row and column. Okay, is everybody roughly to here? Okay, is this an equation?
Yes.
No, not right now. This is just a determinant. What is this supposed to be equal to according to this theorem? It's supposed to be equal to 0. Okay, so here's what we've got. I've got -2 minus 2x plus y minus 2x and then plus 2y equals 0. So if I put these together, I've got, correct me if I'm wrong, -4x plus 3y. And if I move the 2 to the other side, that's going to be a +2. Everybody okay with that? Is that right? Okay. Let's put this in slope-intercept form so we can kind of recognize it a little bit more easily. Okay. So this is going to be y equals, this would be 4/3 x plus 2/3. Correct me if I'm wrong. Okay, there it is. There it is in slope-intercept form. Okay. What form of a linear equation did I say I like best? Do you remember what that was called? Point-slope form. Okay. So y minus y1 equals mx minus x1. You need the slope though, right? How do I find the slope on this? I do, but what if I were doing it from scratch? Okay, difference in the y's. So I'm going to do 2 minus minus 2 over 1. I've got to do it in the right order. 1 minus minus 2. So this gives me a 4 on the top and a 3 on the bottom, correct? There's the right slope. So I'm going to do y minus. Here's the first y. The slope is 4/3. And then this is x minus, let's see, the x is going to be a -2 also. Everybody good there? So I plugged in the first xy pair and I found the slope and all that sort of stuff. Now I just need to see what I end up with if I simplify this. So this is going to be y plus 2. This is going to be 4/3 x. This is going to be a +2, so I'm going to get +8/3. Is everybody okay there? And then I'm going to subtract 2. So this is going to be y equals 4/3 x. And if I subtract 2, that would be 6/3, right? 8/3 minus 6/3 is 2/3, and lo and behold, it's exactly the same thing. Okay? Okay. Any questions? Sure? Okay. If you'll take a look, and I think I gave the same instructions on your homework assignment. Okay, so if you look at this assignment, problems 1 and 2 do on your own. Okay, 5, 6, and 7, if you want to work in teams of 4, that's totally fine with me because those are 3x3s and you've got 4 3x3s to solve on each one of those. Okay, so if you want to work in teams of 4, and then 24 is a bonus, 36 is a bonus. So it's only these 3 that I want you working in teams of 4 on. Okay? The other ones I think you can do just fine. Now, listen up. Tomorrow, I'll take a few questions on 8.4 and we'll correct 8.4. And then I'll take questions on 8.5. So please make sure you've worked on that. I will either have a video up for all of 8.3 over the weekend, and I'll send you an email and everything, or we'll do it old school on Monday and then take questions on Tuesday. Okay? Everybody good?
Can we get the bonus right? Can we get arcade tickets?
Arcade tickets?